Alright, welcome to Chemistry with DeVito. We're going to do a two-part chemical reaction in this video. I'm recording this one because some of my classes meet in a room that does not have this fume hood that currently the camera is inside of, so you can't really see it. But this allows me to do a chemical reaction that makes some, kind of nasty fumes, and then it does not fill up the classroom. It gets sucked into the vent. All right, so those are my classes that are not meeting in this room. You're going to watch the video, so sorry about that, but it is what it is. All right, in the test tube, we have a chemical called potassium chlorate. All right, that is KClO3. Because the chemical has oxygen in the polyatomic anion, this chemical can go through a decomposition reaction to release the oxygen, and the potassium chloride, the KCl, stays in the test tube. All we have to do to undergo this decomposition is heat it up with a Bunsen burner. What you guys are going to observe is this white powdery stuff is going to first melt into a liquid, and once it reaches a certain temperature, it starts to decompose. It will release oxygen gas up the test tube. So the test tube will fill with hot oxygen gas. All right? This chemical reaction is slightly exothermic, and I'll try to demonstrate that to you once we get it going. The reason we know this is true is because once I get it to the point where we have enough activation energy to melt it and to start the decomposition, you can move the Bunsen burner away and the chemical will still continue to decompose. So for that reason, we can tell that it's not an endothermic reaction because it would need a constant input of energy. So I can take the Bunsen burner away, it will continue decomposing. We know it has to be slightly exothermic. It is just slightly exothermic. It does not release a ton of energy. All right? The second part of this chemical reaction, which we're going to do in the exact same video here, is typically called exploding gummy bear, if you want to see other examples of this online. I do not eat gummy bears. You guys know me. I'm pretty healthy. I have a pineapple piece here. Essentially the same thing as a gummy bear. This has, obviously some pineapple in it, but it's also got a lot of sugar. The sugar is what we're looking to react. What we're going to notice once we decompose the potassium chlorate and the tube is filled with hot oxygen is all I need to do is drop this it's not a gummy bear, the pineapple chunk into the test tube, and it is going to go haywire. All right? This shows us a couple of things. In our environment, we live in a planet that has about 20% oxygen in the air. All right? If the percentage of oxygen was much higher than that, humans, we would not be able to live. Animals would not be able to live. Oxygen is the second most reactive element, period. And because of that, it reacts with things very strongly. So when we create in this test tube an environment that is well over 20% oxygen, and the oxygen is a little bit hot because the chemical was hot, it's going to react with the sugar very, very quickly. All right, it's actually going to explode in basically a fireball. I'm going to have to close the fume hood. It's going to make a lot of smoke. All right, and you're going to see a lot of sparks and stuff going off in the test tube as the gummy bear is reacting. So that's the second part. That reaction is extremely exothermic. You will see all the heat being produced, and it also doesn't require a ton of activation energy. I do not need to keep the Bunsen burner on the chemical to keep it going. All right, I'm going to take the Bunsen burner away once it decomposes, and the second reaction will just push ahead full steam. All right, so let's take a look at this demonstration here. Got my Bunsen burner all set. I'm going to put it under the chemical. Okay, I'm also, if maybe you won't be able to hear me, I'm turning the hood on. The vent sucked out try it again there. Okay, so the first thing you should be looking at, you will see the actual crystals start to melt into a liquid at the bottom. This white powder will turn into a clear liquid. It'll look a lot like water. It ain't water. The bottom, you can already see it, is turning into a liquid. I don't think you can necessarily see it in the camera yet. Starting to see the compound fully melt into a liquid. Okay, I'm going to move the camera a little bit closer here. I'm trying to see. See the bottom area? The bottom is a liquid now. Okay? So we're basically ready to drop the pineapple chunk in. The bottom is nice and all liquefied. The top is still a little bit of solid. That's okay. Okay? You can't see it in the camera, but I can see little bubbles forming in the liquid. That is the oxygen being released. Okay? I can now take the Bunsen burner away. It will continue to decompose on its own. It is now a liquid. We put it back here. Turn the gas off. Okay? Ready to go. Okay, and that is the exploding gummy bear. All right, notice the whole thing went nuts as soon as the sugar went in there. The hot oxygen reacted with the sugar. That's a combustion reaction. The carbon fuel was the sugar. The oxygen was the oxygen. We just made a lot of carbon dioxide and water. All the smoke you're still seeing is water vapor. All right. A lot of the KCl is now kind of just like all in the test tube as a white powder coating the entire surface, so the test tube is pretty dirty. But that was the first reaction, decomposition of potassium chlorate, and the second one was the combustion of sugar. All right, hope you enjoyed it.